Hello, hi everyone, good afternoon. So today we are going to learn about concave mirrors. I hope you guys have watched the two earlier videos. One was the laws of reflection, the basic reflection from the plane mirror, and then we have learned the convex mirror. Now it is another spherical mirror which is a concave mirror that we are going to learn today. Alright, we'll learn the basic properties of the concave mirror, then the ray diagrams for the image formation, and then few applications of this concave mirrors. So let's begin, everyone. Yeah, this is about me. If anyone is seeing me for the first time, just have a look at it and we'll move on. So now let's start with the ray diagrams. Hi Adarsh, Sunil, official Abhi Singh. So good afternoon everyone and welcome to our channel. If you have not subscribed, do subscribe. So every day 3 p.m. it's going to be a grade 9 class. Every day 4 p.m. it is for grade 10 class. Okay, so let's learn the ray diagrams. So to understand the image formation, before that, these 4 rays, they are the most important. If you learn only these 4 rays, your life is sorted. You don't have to learn anything else. All this will come from only these 4 rays. Alright, the first one, rays parallel to the principal axis. What is principal axis? In the last class I told you, this imaginary line which is passing from this pole to the center of curvature, this is called as principal axis. Hi Girija, good afternoon. So now the ray is parallel to the principal axis. You see this? There is our incident ray. This incident ray is parallel to the principal axis. What will happen after reflection? It will pass through the point on the principal axis, which we call it as focus. Yes, it will pass through this focus. And why it will always pass through the focus? Because you see this line here, there is an incident ray, reflected ray. The angle between incident ray and what is this? Let's call this point as, let's suppose there is some point here M. So this CM, what is this CM? It is nothing but the radius of curvature, right? So radius will make an angle 90 degrees with the mirror. So this radius will act like a normal, right? So this will act like a normal here. So there is an incident ray and the normal. So this will be the angle of incidence. Normal and reflected ray. So this will be angle of reflection. They are always going to be equal. And that is the reason all the reflected rays, if there is another incident ray parallel to the principal axis, even this one will pass to the focus. You can draw as many rays as possible. All of them will pass through the focus. Hi Sridhar, good afternoon. Alright, so now the second ray, you just have to study or remember these 4 rays. So I am putting more emphasis on these 4 rays. Hi Atanu Kumar, good afternoon. Great, nice to have you all. Second ray, a ray is passing through the focus. You see this one? There is a focus. So when the ray is passing through the focus, what will happen? It will be parallel to the principal axis, right? So now whenever the ray, incident ray is passing through the focus, there is a reflected ray will always be parallel to the principal axis. Again the same properties. The incident ray passing through the focus, there is a reflected ray, there is an angle of incidence, angle of reflection. They are always going to be equal. The next one, a ray is passing through center of curvature. C is our center of curvature. So when the ray passes through the center of curvature, what will happen? Now this center of curvature, this line here is nothing but the radius of curvature. That means this ray is along the normal, right? This ray, incident ray is along the normal. So in that case, the reflected ray will retrace backwards, right? So here angle of incidence is equal to 0 degrees. So So angle of reflection again equal to 0 degrees. Okay. Practically, what do you mean practically? Yeah, we'll learn some applications or uses of these mirrors, but this will come in your exam. So you should learn this if you want to get a good score for your grade 10. Okay, now when the incident ray is passing through the center of curvature, reflected ray will retrace backwards because it is along the normal, right? Something like this. And the last one, a ray which is going to fall at P. So now this somewhere here is our center of curvature. So this line, this dotted line, or the principal axis is our normal. So there is a normal, there is an incident ray. So this will be the angle of incidence, right? So this will be the reflected ray and angle of reflection. There is a reflected ray. So just remember these 4 rays and you can draw any type of image formation for the concave mirror. Alright, so let's match the following. Can you match these? Here, incident ray is parallel to the principal axis. If the incident ray is parallel to the principal axis, what will happen to the reflected ray? It will pass through the focus. Then incident ray is passing through the focus. What will happen to the reflected ray? It will be parallel to the principal axis. Hi Nikhil, good afternoon. Third ray is passing through the center of curvature. Then the reflected ray also pass through the center of curvature. And the fourth one, a reflected ray is directed towards the pole. So it will make an equal angle to the principal axis. Nice, Atanu Kumar, good afternoon. Great. So let's learn the image formation. So you have learned the 4 most important rays. Now the important thing is to learn the image formation. How? Let's suppose if you keep an object in front of this concave mirror, how it is going to form the image. So let's understand that. The first one, object is at infinity. So which object can you call it as infinity? The object which are very far. There is an object which is very far from this mirror, and how will you decide which object is very far? Something like a sun or moon. These are objects very far. But not just that, let's suppose this is the center of curvature. So this will be the radius, or from the focus to this pole, there is our focal length. So let's suppose if this distance, this is called as object distance u. Distance of the object from the pole, it is this u. If u is much greater than radius of curvature, then we can say that this object is placed at infinity, right? There is a general way to say. So you don't have to have always sun or the moon. Even the tree which is like 10 kilometers away from the mirror, that can act like a object at infinity. Alright, so now these are the incident rays. You see all of them? All these incident rays, they are parallel to the principal axis. So what will happen? They will all converge at a single point called as focus. So what will happen? This is a converging mirror. So in that case, what is happening? The image, there is an object. For this object, will get the image at this point. So this rays, they are meeting physically, right? They are converging. So if the reflected rays meet, that is a real image. So what are the properties of this image? Okay, I'll remove this. So image is formed at the focus. It is highly diminished, real and inverted. So these are the properties of this image. Why it is highly diminished? You see the size of the object. There is the size of the object, but the image is like a point size. That is why it is highly diminished. And there is a real image. So whenever you get a real image, it is always together. Real and inverted, they are always together, right? What are the assumptions we are assuming in the curved mirror? So there is one simple assumption that the incident rays are near to the principal axis. There is the only assumption that we are making. Okay, real image means if these rays they meet, so there is a rays are actually meet at this point. So when the reflected rays they actually meet, that point or that image is called as real image. Okay, in the plane mirror we have seen the image is forming behind the mirror, right? So that was the virtual image, because in that rays were going away from each other, they were diverging. So if the reflected rays are diverging, that it will be the virtual image. Yeah, we'll solve, Padmini, the questions, something like the similar questions in the next class, alright, after we learn the mirror equation. So to solve this question, we have to learn the mirror equation. After that, we can solve all these questions. Okay, Padmini? Alright, what are the assumptions? So swap assumption is the incident rays are always falling on the mirror on this curvature which is very close to the principal axis. So only these rays we are going to consider. The other rays, let's suppose there is a ray falling on the mirror at the sides or corners. So these rays we are not going to consider. That is the assumption. They are difficult to study, right? Once you go to 12th, you will study even these kind of rays. Alright. Totally in front of the mirror, only at the focus inside the concave mirror. Yes, we are going to study that case as well. When you see the inside the concave mirror, so that is going to be virtual image, right? So we are going to learn that case as well. So now you bring the object. Earlier object was at infinity. See, this object is at infinity. You bring the object a little closer. So now the object is beyond C. This is our center of curvature. Object is further away from the center of curvature. Now there is an incident ray. There is a parallel to the principal axis. What will happen? It will pass through the focus. Now to get the image, we need two rays. Yes, there is a first ray, first incident ray and the reflected ray. So we need another ray. So let's consider this ray which is passing through the center of curvature. There is a second incident ray. Now it is passing through the center, so it will retrace backwards. So it will retrace backwards here. There is a reflected ray. So now these two reflected rays, they meet at this point. These reflected rays, they actually meet. So whenever they actually meet, you will get the real image. So this is going to be the real image. Okay. So what are the properties? Image is formed between C and F. C is the center of curvature, F is the focus. That is the position of the image. Now it is diminished. Diminished means smaller size. You see the size of the object, size of the image. So image has a smaller length compared to the object. Again, these are real and inverted. So whenever you get a real image, it is always going to be inverted. Okay. Now the next one, you bring the object even closer. When the two rays converge, how does the image form? You can take a screen. So here what you can do is, you can take a screen like some cloth and try to get the image on that cloth. So you'll see, so this rays, so in general, in reality, there are like thousands or millions of rays, they are coming from this object, falling on the mirror, and we get the image. But you cannot draw millions of rays, right? So we can only draw two rays. These are enough to get the proper image position. Alright. So this is the way we can represent to understand the physics behind it. You don't have to show hundreds or thousands of rays coming from this object. Alright. समझ में आ रहा है? Manat Kumar, clear? How does an image form? Yeah. Alright. So now the object is at C, that is the center of curvature. You place the object at the center of curvature. Earlier at infinity, then beyond C, now at center of curvature. So what will happen? Again, there is an incident ray. There is a parallel to the principal axis. This one is the reflected ray passing through the focus. You need another ray. There is a second ray passing through the focus. So what will happen? The reflected ray would be parallel to the principal axis. So image will form, there is a point of intersection. So there is a point where these two rays meet. So there is an image. This is our object and image. So how can you be sure that image will form only at this place? So what you can do is, you can take a screen, place a screen at this point, at this position, and you should get a sharp image. That is the meaning. Alright. Hi Aisha, Parveen, good afternoon. Yeah. So this is the only point in front of the concave mirror where the height of the object and height of the image, they are equal. So the image is same size as the object. It is again real and inverted, formed at C. These are the properties of the image. Clear? Everyone? Awesome. So now object is, again we moved the object closer to the mirror. Object is now between the focus and center of curvature. So there is an object, incident ray falling on the mirror, the reflected ray passing through the focus, second ray passing through the focus, and reflected ray. So they are going to meet at this point. Now this will be the image. You see the object and you see the image now. Earlier the image was smaller. Now there is a point where image is going to become larger, right? Object and image. So image is larger in height. Not just that, it is broader. Can you see the width of the image? It has increased. Clear? So what are the properties? Where is the image formed? Image is formed beyond, see there is a point C, center of curvature. Image is formed beyond or further away from the center of curvature. There is an enlarged. Image is larger than the object and real and inverted. Clear? Now last two cases. Again we are going to shift the object closer to the mirror. Now if you bring the object at focus, so this is our focus. You keep the object at focus, what will happen? So this is the incident ray parallel to the principal axis, reflected ray passing through the focus. We need one more ray, right? So now let's just assume this ray is passing through the center of curvature. There is some ray which came from the center of curvature, it touched the top of the object and fall on the mirror. So now it will reflect backwards from the center of curvature. Now you look at these two rays, both of them are reflecting rays. Now these reflected rays, they are never going to meet. Why? These are the parallel lines. So are these going to meet? Either they will meet at infinity or they are never going to meet. So what we can say is that the image will form somewhere here. It is going to be highly enlarged. So image will form at infinity. It is going to be highly enlarged. You see the object, you see the image. Image is very large in size, real and inverted. Clear? So until now we looked for the images which are real and inverted. So now if you bring the object even closer to the mirror, something interesting is going to happen. Let's see that. Now the object is between focus and pole. There is our focus, there is a pole. So what will happen? There is the object, again the incident rays parallel to the principal axis, it will pass through the focus. The second ray, this ray is coming from the center of curvature. It will get reflected backwards. Now look at these two rays. they are diverging. These rays, they are diverging or going away from each other. So in that case, they are surely never going to meet. So what we do is, we retrace them backwards. You see, there is a backward retracement. And when you retrace backwards, so there is a point where they appear to meet. They are not physically meeting, they appear to meet. So that will give you the image. So this is a position. What is the position? Behind the mirror. That is the position of the image. So let's learn about the images. Image is formed behind the mirror. It is enlarged. That means the object compared to the object, image is larger in size. It is virtual and erect. So this is the only point where you should keep the object to see in the mirror. Somebody was asking, how can you see the image in the mirror? If you want to see the image inside the mirror or behind the mirror, that is going to be the virtual image. It will form only when the object is between focus and pole. Why they can't reflect upwards? What do you mean? Yeah, if you place the object something like this, if there is an object, this would be the incident ray, then this would be the reflected ray, this would be the reflected ray. If you place the object downwards, the reflected rays would be upwards, right? What is the focal length of the eye? It is the same as size of the eye. So whatever is the size of the eye, you can measure, that would be the focal length of the eye. Alright. Now there is a summary of all the image formations for the concave mirror. You place the object at different location, you get their images at different location. Important thing is, when the object is at infinity, at center of curvature, then image is at center of curvature, it is the same size. Okay, and all of these are real and inverted. Only the last one is virtual and erect. Only the last one is virtual, all the others are real and inverted. At infinity, there is a point size or highly diminished point size image. If you place at focus, there is going to be highly enlarged. Can you see? They are going to map at focus, at infinity, at center of curvature, at center of curvature. This is beyond C and this one is beyond C. You can see the mapping. So that is very symmetric. When you go from infinity to the focus, this image will move from focus to infinity, right? So there is a very symmetric nature in the image formation, and this one is the only place where you get a virtual and erect image. Clear, everyone? All right, let's solve some questions based on this. Can you solve? Try to solve. Type your answer in the chat. Okay, I'll read the question for you. Concave mirror gives real inverted image, but the main important point is it is the same size as the object. So when you get the same size, yes, Vinod, correct. When you place the object at center of curvature, then you will get the same size image. Nice, Zara, awesome. All of you, great. At the center of curvature, correct. Not at the curvature, at the center of curvature. Curvature is this mirror, which is the curvature. This we call it as a curvature. So not at the curvature, at the center of the curvature. This is a curvature, that means a sphere. So center of this sphere is our center of curvature. Okay, Vinod? Great. Now the next question, concave mirror focus a real point size image at the focus. So this is a point size image. So where should you place the object to get a point size image? Check. We want a point size image at the focus. So there is only one point where you can keep the object, and that is at focus. No. Between focus and center of curvature? Again, no. At center of curvature? Again, no. So where should you place the object? You should place the object at infinity. Then you will get a real point size image at the focus. We have learnt all these cases, right? You remember? Vinod, Zara, nice. Bimla Kumari, solve this. So for a real object, which of the following can produce real image? Real object means, let's suppose I'll draw, there's a plane mirror, there's a concave mirror, and there's a convex mirror. Real object means you place the object in front of the mirror. That is the meaning of real object. Can produce a real image. So what is the meaning of real image? The image also should form in front of the mirror. So image should form, if you place there's a screen, so you should form the image on the screen. That is the meaning of real image. So which of the following is true? If you use a plane mirror, image will always be behind. If you use a convex mirror, again image is going to be behind the mirror. So these two cases cannot give you the real image. So plane mirror, not correct. Convex mirror, not correct. How about concave? In the concave mirror, if there is an object, if you place the object at any point between infinity and focus, it will give you the real image. Yes, concave is correct. So concave mirror only can give you the real image. Nice everyone. Nice Bimla Kumari. Correct. Vinod, awesome. Now somebody was asking me, what is the practical application? Why are we learning all this? Do we have any practical applications? And absolutely. Otherwise, why are you wasting your time if there is no application to this? So let's learn some uses. So where do you use this? Concave mirrors. They are very complicated applications. We are going to learn some simple, like in daily life. Where do you use the concave mirrors? First one, let's suppose you place a source at the focus. So something like this, there is a battery here, there is a battery which is focused on the mirror. So these are the incident rays coming from the battery, and there is a point which is focus. So what will happen? So these rays, they are coming, these are the incident rays coming from the focus. So what will happen? These are the reflected rays. These are all reflected rays. And what do you see common in that? All these reflected rays, they are parallel to each other. Yes, all 5 cases form real image, correct. So these reflected rays, they are parallel. So where can you use it? This property of the concave mirror. And the application is, you see this torch or the headlights of your car or bike, or this, there's like a beam. If you want to produce a parallel beam of light, then we use the concave mirror. So small bulb is placed at the focus, and because of that you get this beam of light. So if you place it in your car, so car can produce a light which can run, which can go to kilometers, and you can see the road, right? So these are the applications of concave mirror. There is a one, there are many more coming up. The next one, if you place the object between the focus and pole, what are the properties you remember? These are the rays, different rays. We know this ray diagram. So the image is going to form, there is an image. And what are the properties? There is an enlarged and erect image. Erect means upright. Erect means the object is pointing upwards, image is also pointing upward. That is the meaning of erect. And there is an enlarged. If it is a concave mirror can also produce a virtual and erect image, but in the plane mirror, it is a virtual and erect image, but it will be same size. We want enlarged image. So we can use concave mirror. And where do we use this? So people can use in their shaving, like these are the shaving mirrors. If you want to do the shaving, then this will help you out to identify the small hair on the face, or the dentist use it to see the cavities in your teeth. These are some of the applications used in shaving mirrors to see the larger image of the face, or dentists use it to see the cavities or some other, if there is any problem with your teeth. Okay, for conservation of conversion of light. All right. Now the third application. So object, there is our object at infinity. So these are the incident rays which are parallel to the principal axis. What will happen? They will all converge at focus. So where do we use this property of the concave mirror? And there is a device called as solar cooker or solar furnace. In that, these are the solar furnace. So all these incident rays, you see these incident rays, they are coming from the sun. So somewhere here is the sun. So from the sun, the incident rays, they fall onto the concave mirror. What will happen? All these will be reflected to the focus. Something like this. So there is a point, focus. So we keep a furnace that is called a solar furnace. So it can be used for several applications. You can use it as a solar cooker, or convert, like keep a beaker which contains water. So you convert that heat energy into steam and use that steam to convert the electricity, right? So there is a electric, you can convert the solar energy into electrical energy using this concave mirror. So these are the certain applications of concave mirror. All right, solve this question. So which mirror or mirror that can give enlarged and erect image? You remember what is enlarged? Enlarged means larger in size, and erect image. So when do you get the erect image? When it is a virtual and erect, right? Whenever it is a virtual, it will be erect. So let's suppose we have three different mirrors. This is a plane mirror, concave mirror, and convex mirror. Something like this. So if you place an object in front of the plane mirror, it will give you the virtual image, but it will be same size. If you place it in front of the convex mirror, this will be the image. There is an object, there is an image. Again there is an object, there is an image. There is a same size. Image is same size. This one is diminished. Diminished meaning smaller in size. And if you keep it in front of the concave mirror, this will be the image. There is an object, there is an image. This one is enlarged. Enlarged meaning larger in size. Image is larger compared to the object. So which mirror can give you that? It is our concave mirror, not the convex, not the plane mirror. Clear? Easy, right? Alright, so that's it for today. Thank you so much. In the next class, so we'll have every day 4 p.m. is grade 10. So in the next week, we are going to learn the most important topic, that is the sign convention. And a lot of you make a lot of mistakes. So we are going to learn it very thoroughly in the next class. So till then, bye bye, take care, enjoy.